Good morning. I just wanted to start lesson 5 today, and I'll be posting that today and then the unit review by tomorrow. So you're able to test this week on unit 9 or early next week. So today we're going to be going over another topic of quadrilaterals called kites and trapezoids. So we're going to be doing the guided practice. Um, on page 844. We are doing number 1 through 4, 6 through 7, and then the independent practice as well, which is number 8 through 12, 24, 33, and 34. So essentially, number 1, we have what's known as a trapezoid. A trapezoid, there's properties that I want you to pay attention to. There's a couple examples. This is from page 839. So from page 839, there are specific properties of trapezoids. So when we look at this example, this angle, when we have a trapezoid and its opposite angle down here, they add up to 180 degrees. So we could say that the measurement of angle DAB plus the measurement of DCB or BCD, it doesn't matter. I'll just say DCB equals 180 degrees. So when we look at this, we're trying to find the measurement of angle C. And when we look, we know that the measurement of A plus the measurement of angle C equals 180. We're just going to plug in 120 for angle A, and then we're going to have the measurement of angle C equals 180 degrees, and then we're going to just subtract 120 degrees from both sides, and we're going to get the measurement of angle C equals 60 degrees. So that is the solution for number 1. We have these opposite angles and a property that states for the trapezoid that the opposite angles add up to 180. So you could just take 180 degrees, subtract 120, and you get 60 for this angle. So that's 60 degrees. All right, number 2. This is again from page 844, I believe. Let me just flip to that section. So we have another trapezoid that looks like this. And it's E, F, G, and H. And we have diagonals that connect the opposite angles. And EF is parallel to HG. And those legs are congruent for FG and EH. And it says find, they want you to find EJ, and they say that HF, so HF is equal to 50, and then JG is equal to 10. So I'm just going to draw this out. So HF, this diagonal right here, is equal to 50. So what I could do is, I know I should have did a different color. That's 50. And then JG, this little segment right here, is 10. And it wants to find EJ. So it wants this portion right here. I'll just label that as X. So we know that based on the properties of um, trapezoids that the diagonals are congruent. So we know that EG, diagonal EG, is congruent or equal to HF. And we know that HF is equal to 50. So we know that this is equal to 50 degrees, or sorry, not degrees, 50. Okay, and EG is equal to EJ plus JG. That's EG, because we have this portion EJ that we're trying to find that we labeled as X, and then we have JG, which is 10. I labeled it right here. Okay, so EJ is X, we don't know what that is, and JG, it was given that it's 10. So that's going to equal EG. We have this expression, X plus 10. So what we're going to do is now have X plus 10, because that's what EG is, equal to HF, which is 50. And then we're just going to subtract 10 to both sides, and we're going to get X equals 40. And therefore, EJ is equal to 40. All right, so now we're going to move on to question 3 and 4. I'm going to give you a second to write this down, and then we're going to move on. Okay, so question 3. It says quadrilateral JKLM has vertices at 310, 26, 11, 6, and 810. Verify that JKLM is a trapezoid. So what we're going to do is we have a quadrilateral JKLM, and J is at, again, 310. K is at 26, and L is at 11.6. And M is at 810. So what we could do now, I'm just going to graph. So J is at 310, which is right here. K is at 2.6. All right. L is at 11.6. So right here. And M is at 8.10, which is right here. And if we draw these points, it looks like that. All right, so it wants us to verify if basically this is a trapezoid. And so what we're going to have to do is find the slopes of each of the sides to verify if this is a trapezoid. And what we're going to do is look at the slopes of each side. So we're going to look at the slope of JM, the slope of KL, the slope of ML, and the slope of JK. All right, so the slope formula, I'm just going to write up here, is y2 minus y1 over x2 minus x1. So we're going to do that for our points, or our sides of the trapezoid, if it is a trapezoid. Just whatever quadrilateral we're looking at right now, we're going to find the slopes of the side lengths. So J's points at 310, and M is at 810. So I think what I'm going to do is erase that. And we're going to just plug it into this formula, the slope formula that I just wrote up here. And so I'm going to go 10 minus 10 over 8 minus 3. That's going to be 0 over 5, which is 0. So Km slope is 0. All right, and now we're going to look at KL slope. And we're going to have K is at 2, 6. And L is at 11, 6. And so we're going to, again, go 6 minus 6, 6 minus 6, over 11 minus 2. That's going to be 0 over 9, which is 0. So KL slope is equal to 0. I'm just circling it just to let us know. So these two slopes are the same. So we know it's parallel. And now we're going to look at the slope of ML and JK, and that's going to help us verify if it is a this quadrilateral is a trapezoid. So M's coordinate is at 8, 10, and L is at 11, 6. So we're just going to plug it in. We're going to go 10 minus 6 over 8 minus 11. So that's going to be 4 over negative 3. So ML's slope is 4 over negative 3. All right, so now we're going to find JK's slope. Okay, so J is at 310 and K is at 2, 6. So we're going to plug in and go 10 minus 6, 10 minus 6 over 3 minus 2. So that's going to give us 4 over 1. So JK slope is equal to 4. All right, so since we have those slopes and these slopes are not the same, basically we know that this quadrilateral, let me look to see what I'm looking at from the example. Sorry, just give me a second. Okay, so since we know that this quadrilateral has opposite sides, one pair of opposite sides that are parallel, these two sides, ML and JK, are not parallel. If they were parallel, these slopes would be the same. So since we have one pair of opposite sides, JM and KL equaling 0, we know that this quadrilateral is a trapezoid. So yes. So JKLM is a trapezoid based on one pair of opposite sides having the same slope and the other two opposite sides have different slopes. So that is number 3 of the guided practice. All right, so we'll be moving on to number 4, which has to do with this problem, and it wants to know if this trapezoid is an isosceles trapezoid, meaning is JK and ML the same length? Are these two sides congruent? I could tell you by looking at them based on the way that we drew it, they are not. It isn't a isosceles trapezoid, and what I'm going to do is show you why this is the case. So in order to verify if these two sides, JK and ML, are congruent, we have to use the distance formula and solve for both of them. And if they're equal to each other, then we know that they are in fact congruent, and therefore it would be an isosceles trapezoid. So we're going to use the distance formula. Again, that's x2 minus x1 squared plus y2 minus y1 squared. And it's the square root of this whole expression. And so what we're going to do is we take j and k. So j's side, trying to find my eraser. Here it is. J's coordinate again is equal to 3, 10, and k's coordinate is 2, 6. So we're just going to plug this in to this equation. So we're going to have 3 minus 2 squared plus 10 minus 6 squared. And that's going to be 1 squared plus 4 squared, which is the square root of 17. And we're going to do the same thing for ML. M's coordinate is at 8, 10, and L is at 11, 6. So we're going to take the square root, again, of x2 minus x1 squared plus y2 minus y1 squared. That's the distance formula. So we're going to go 11 minus 8 squared, 11 minus 8 squared, plus 6 minus 10 squared. And that's going to give us the square root of 3 squared plus negative 4 squared, which is going to be the square root of 9 plus 16, which is the square root of 25, which is 5. So since the distance of JK does not equal the distance of ML, this is not a isosceles trapezoid. We can't say that these two sides are congruent. So we're going to say JKLM is not an isosceles trapezoid. And that would be number 4. So I am going to continue on and do number 6 and 7 in a second, since this video is almost 18 minutes long and I have class coming up soon. I am going to pause and then finish the rest of the guided practice, number 6 and 7, and then do the independent practice. All right, I will have this up for you later today. Thank you so much, and I will see you in class.